Hi, welcome back, intro stat students. So today we are doing this exercise, calculating the p-value, right, in z test for proportion. P-value is really, really important, right? And I need you to understand what we're trying to do today. So let me click on this, all right, and we can just kind of so. So let's read through this. Okay. Amanda read a report saying that 49% of teachers in the United States were members of a labor union. She wanted to test whether this was true in her state. So she took a random sample of 300 from her state to test. So the null hypothesis, the H naught is the population P. P, by the way, stands for or represent the population proportion of teachers in her state who are members of the labor union. So P equals to 0.05 versus the alternate hypothesis is P is not equals to 0.49. So it could be more, it could be less. Okay, so it's a two-tailed test. The sample results showed 134 students were members of a labor union, and the corresponding test statistics was z star or z sorry z equals to approximately negative 1.5, assuming that the necessary conditions are met. What is the approximate p-value for Amanda's significance test? You may round to 3 decimal places. I need you to remember this calculator function, okay? Because this is going to really be very, very helpful to you. All right? So, what you need is understand this. So, when you go to stat and then you go to test, right? So here we are looking for proportion, right? I know on the test it will not tell you whether is it a proportion or mean. You need to read the question and look for if it's a p, it's a proportion problem, right? If it's a p, if it's a mu, it's a mean problem. Okay, so it is a p. So we are looking at a one proportion z test. Okay, one proportion z test. So let's run through this. So go to stat, go to tests, and then scroll down to one proportion z test. Now why z test? Because this proportion is always z, right? Proportion is always z test, and there's only one proportion we're looking at. So if you press enter, and then they will ask you, okay, what is your population proportion to begin with? So it was 0.49. We always look at the null hypothesis. That's our original claim. So we put it here, 0.49. So where's the x? Where the x come in? X means it's the sample. The sample showed 134. So I need to click here. The x is 134, the total number of success. Here, out of how many? Out of 300 students, teachers, only 134 were members of the labor union. Right? So I need to change the sample size to 300. Now, which one am I going to pick? Am I going to pick not equals to, less than, or greater than? We choose the one that we say in our alternate hypothesis. So our alternate is not equals to, so we go to not equals to. Right? And when you click that, ladies and gentlemen, the middle row, you see that? That's your p-value. Right? It says p equals to 0.133, and we're supposed to round this to 3 decimal places. So 0.133. Woohoo! Okay, next question. a campaign manager for a political candidate released a series of advertisements criticizing the opposing candidate in an upcoming election. The opposing candidate previously had the support of 45% of voters. So the manager wants to test H naught right here is the population proportion of voters that support the opposing candidate, and that's equals to be 0.0545 versus that you're suspecting that it's less, right? So P is less than 0.45. After running the advertisements, the campaign manager obtained a random sample of 500 voters and found that 200 of them sample supported the opposing candidate. So you have a few options. You have A is that looks like a binomial formula, like 500 choose 200, and then 0.45 raised to 200, and then 1 minus 0.45, which gives you 0.55, raised to 300. And you see that 300 plus 200 gives you 500. So this is not a binomial. To find the p-value, it's not using binomial, right? That doesn't work that way. So we need to do this, right? We need to figure out, okay, to find the p-value, basically we are trying to do this, and this is trying to use, give me a second. What's up?
I just retook the test. Exam 3.
Right, sorry about that. A student just came in. Okay, so what I was trying to say is p-value is a probability, right? And to calculate probability, sometimes we do this. The p, the symbol p, and okay, p, and then the z, right? So for p, for this proportion is always a z-test, right? It's a z. We're calculating it on a normal distribution, right? Normal distribution with a mean, right, of 0.45, I believe. I believe the mean is 0.45. Yeah, right. That's the null hypothesis. Mean is 0.45. And the sample was right here, 0.4. And we're trying to find this portion here. So this is my p-value. The area under the curve is like how likely is this sample, right? This sample of zero point 0.4, right, as extreme or more extreme. That means I'm not just content to find, okay, what does the probability happen when this is 0.4, right? When my sample is 0.4. Because when I look at my sample, when it's 0.4, yeah, it is less than 0.45. But is it how much less? Is that enough for me to say, you know what? The null hypothesis is false. 0.5 to 0.45, it's not much difference, just a tiny little bit. So I'm trying to find, okay, 0.45 as extreme or more extreme, which is this direction down, because our alternate hypothesis was what? Our alternate hypothesis that it's less than 0.45. But how much less? This is what we need to find. So here, the formula for this is P is less than P hat minus P divided by square root of P times 1 minus P divided by N. So if you were to substitute all the values in, P hat we found to be 0.4 minus P, we know it's 0.45, divided by square root of 0.45 times 1 minus 0.45 is 0.55 divided by 500. I believe the sample size was 500. So this is what we need to calculate, right? This is what we need, because this is your Z statistics formula. right? Statistics formula, and that will give us the number of standard deviation of zero point 0.4, right? How many standard deviation is zero point 0.4 away from 0.45? And then you can use that to calculate the probabilities, right? Um, so by looking at the question, the option, it looks like it's zero point 0.4 minus 0.45. Is it more than? So we cannot pick more than, right? We are not picking more than, we're picking less than. So this would be it. Okay. So let's do one more quickly. A ketchup company regularly receives large shipments of tomatoes. For quality control purposes, they take a sample of tomatoes from each shipment. If the sample shows convincing evidence that more than 8% of the tomatoes in the entire shipment are bruised, then the company will request a new shipment of tomatoes. So the company tests, right? They cannot test the whole entire shipment. They can only do a sample. But the null hypothesis is that we assume that the P, which is the proportion of tomatoes in the actual entire shipment that are bruised, is only maintaining at 8%, 0.08, versus more than, right? If it's more than 8%, then we request a new shipment. So the null is zero point zero 0.08. The alternate hypothesis is more than 0.08. All right. One day, a supervisor takes a random sample of 600 tomatoes from a shipment and finds that 53 of the tomatoes are bruised, which results in the test statistics of 0.577. These test statistics of 0.75. Okay. Now I need to explain something. This 0.75 was calculated using this. P hat minus P divided by square root of P times 1 minus P divided by N, right? Where P is 0.08, P hat is 53 divided by 600. That's your P hat, your sample proportion. And then here the P is 0.08. 1 minus P, that means 1 minus 0.08, and N happens to be 600. So this, right, when you put all the values in, it's approximately 0.75. That means this particular sample proportion is 0.75 standard deviation away from the mean, right? So a standard normal distribution, 0 is here, 0.75 is here, and we are shading to the right because of this. We are looking at P greater than 0.08, so we're going to the right. Okay, so this is 0.75 right here for this particular sample. So we are trying to find this. This is my p-value. This whole area is my p-value. Now there's an easy way to do this on the calculator. All right. So what we do is let's clear this. Go to stat, go to test, and then we go to one prop z test, one proportion z test, and you press enter. So we need to put down the population proportion, which is 0.08 right there at the first line. And then X is the number of success. Here the number of success is 53 of the 600 were bruised. So 53, I put 53, and then 600 here, sample size. Now which one do we pick? Not equals to, less than, greater than. Always pick the arrow following the alternate hypothesis, which is this one, greater than. And when you press enter, the P, ladies and gentlemen, the P value is 0.226, round to 3 decimal place, 0.226. Right. I hope this makes sense. If you let me know if you need any help. Thank